LSD method, or least significance difference, or in some books they write it down, Fisher least significant difference method. We use it for the multiple comparison. So it's an equation that we use for the multiple comparison. The standard error of the difference between two means, if you go and check chapter 1, you will see that is equal to the square root of the 2 times S2 divided by n. If ni and nj they are not equal, then we would approximate it by the like their average n bar. For the diets, for example, for the diets example, we would say n bar is equal to 6, and then the standard error is going to be 2 times 5.6. So this 5.6 is the S2 that we need to calculate, divided by 6, and then so we will find out the standard error. Also from table, we would find out for the t with the degree of freedom of 20, and then half of the alpha is 0.025. We find out the t from the table is 2.086. So therefore, a difference between a specific pair of means is significant at the 5% level if it exceeds this number. So this number, like we would say 2.086 times 1.36. So this is the LSD method, LSD equation, equal to 2.85. So if the difference between a specific pair of the means of those diets that we had, if it exceeds this number of 2.85, then we will say it's going to be, the difference would be significant. To apply the LSD to all means, use the previous result involving the Ben-Perroni inequality. So we'd say k equal to 4, k times k minus 1 divided by 6 is going to be 6 combination, and we would choose b equal to 0.05. So alpha is going to be like the upper bound, the target for the upper bound, it would be 0.05. So alpha is 0.05 divided by 6, could be 1%. And then we would say t at the 0.005, like half of this new alpha that we found. And 20 is 2.845. So LSD number is going to be 2.845 times 1.366, which is going to be equal to 0.89. So the least significant difference is 3.89. Any difference greater than this, it's going to be, we would consider the significant one. So basically it's like this. We are going to find out t value from the table, multiply it by the standard error, and it's going to give you the LSD value. So now let's look at this. These are the means for the different diets that we had, like 61, 66, 68, and 61. So then you can get the, subtract them. After you did it, you can pause the video and do that by yourself and then compare it with the LSD number. So therefore, we can distinguish between diet A and B, diet A and C, B and D, and C and D. It's like, just say that what's the difference between, for example, get the absolute value. Between B and A, like B and A is 66 minus 61, it's going to be 5. So 5 is greater than LSD number. So we would say that diet A and B, the difference between them is significant. However, we cannot distinguish between the diet A and D because it's 61 and 61, so the difference is 0, is less than 0.89. Or B and C, so 66 and 68, the difference is 2. 2 is less than 0.89, so we cannot distinguish between them, between these two diets. Look at tutorial, as a practice problem, look at tutorial with the name of chapter 4, and then example 2. So in the tutorial, it talks about all of this. let's have a concept map, because we had like everything that we had in this chapter, it was new, right? So for single factor design of experiment, we compare the variability between treatment levels and within treatments. If we have two levels, then we would we would use the t-test. If we compare more than two levels, in that case, we would have the ANOVA. We would use the f-test. The multiple comparison for more than two levels, we could use Bemperoni t-test. And if you want to distinguish between levels or not, like we would say that, for example, when we say levels, is levels of treatment. So I have the treatment as a diet. So my factor is diet. So I have one single factor, which is diet. And then my diet has 4 levels in it, 4 levels of the treatments. The distinguish between levels or not, and we would use the LSD method. So we would say, for example, we can distinguish between treatment A and treatment B. So that's the LSD method. So that's all for this chapter. Make sure that you are going to look at review the example that we had here, also the example that we have in the tutorial or practice problems. And then if you have questions, please let me know, so we can meet, or I could mention that in our like summer sessions.